Density tells you how tightly packed the mass is inside a given volume. Mathematically, density is mass over volume. The symbol for density is called rho. If two cubes A and B take up the same volume, and cube A weighs more than cube B, we say that cube A is denser than cube B. If both cubes share the same mass, but cube B takes up more space or volume, we say that cube B is less dense than cube A. Let's move on to the first question. The standard kilogram is a platinum iridium cylinder, 39 millimeters in height and 39 millimeters in diameter. What is the density of the material? In physics and engineering, density is usually given in kilograms per cubic meter for larger objects or fluids, and grams per cubic centimeter when dealing with smaller objects or fluids. To find the density of the material, we need to know its mass and volume. We know that the mass is 1 kilogram, and we have the height and the diameter of the cylinder. All we need to do is find the volume of the cylinder, which is pi r squared h. So first, we convert the lengths from millimeters to centimeters. 1 centimeter is 10 millimeters. The diameter is 39 millimeters, which makes the radius 19.5 millimeters, which is divided by 10, making it 1.95 centimeters. And 39, the height being 39 millimeters as well, gives us 3.9 centimeters. So the density rho is going to be m over v. The mass is 1,000 grams. The volume is going to be pi r squared times h, which means it's going to be pi times 1.95 centimeters squared times h, which is 3.9 centimeters. And that's going to roughly equal to 46.6 centimeters cubed. Now we can just plug in the values of mass and volume into the density function. So rho is equal to 1,000 over 46.6. This is in grams, and this is in centimeter cubed, and this is going to equal 21.5 grams per centimeter cubed. Moving on to the next question, we're asked how many grams of copper is required to make a hollow spherical shell that has an inner radius of 5.7 centimeters and an outer radius of 5.75 centimeters. And we are given the density of copper to be 8.92 grams per cubic centimeter. The volume of a sphere is 4 over 3 pi r cubed. And the volume of our hollow spherical shell is simply 4 over 3 pi times the radius of the outer shell minus the radius of the inner shell. And this will be around 20.6 centimeter cubed. We know the density of something is mass over volume, and the mass would be rho times that volume. So mass, we could just plug and chug 8.92 grams per centimeter cube times 20.6 centimeter cube, and this will equal around 1.84 times 10 to the power of 2 grams, which equates to 184 grams of copper required. For the next question, we're given the molar mass of iron to be 55.8 grams per mole, and we need to find the volume of 1 mole of iron, which is called the molar volume. 1 mole is simply a huge number, which is 6.022 times 10 to the 23rd. Molar volume which is how much space 1 mole of iron atoms take up, is the molar mass, which is how heavy 1 mole of iron atoms are, divided by density. We have both of these values, so we can just plug it in, and we get roughly 7.09 cubic centimeters. For part B, we want to find the volume of one iron atom. We know that volume is mass over density. However, we can't mix the mass of 1 mole with the density of an atom. We can't apply mass over density directly unless we know the mass and the density of a single atom, and we usually don't. But we do know this. We know that 7.09 cubic centimeters of space holds 1 mole of atoms. So we can just divide 7.09 cubic centimeters by 1 mole, and this will give us the volume of one atom, which is approximately 1.18 to the 10 times 10 to negative 23 cubic centimeters. Cool. Now, moving on to part C, we're trying to estimate the distance between atoms in the solid. So we know the volume of each atom in cubic centimeters, which means that given each atom occupies a tiny cube of space, the edge length of that cube is the cube root of the volume. So doing the calculations, you'll get approximately around 2.3 times 10 to the negative 8 centimeters. For part D, leave your answer in the comments.